Hello everyone. Today's topic is IR radiation and greenhouse effect, presented to you by Alex, Luis and Ceron.
So, let's start by talking about IR radiation. What is IR radiation? IR stands for infrared. IR radiation is known to be a specifically bound region of the electromagnetic spectrum that extends from the long wavelength, which you can see is red in color, to the microwave range. It is a type of electromagnetic radiation where frequencies are continuously produced by atoms that absorb and release energy. All matter emits IR radiation, with the hotter objects emitting a larger amount of IR radiation over a given amount of time. This type of radiation is not visible to the human eye, but it can be felt as a sensation of heat. The largest source of incoming IR radiation for Earth is from the Sun. Radiation in the electromagnetic spectrum is often categorized by wavelength. Short wavelength radiation is of the highest energy and can be very dangerous, such as gamma, X-rays, and ultraviolet are examples of short wavelength radiation. Longer wavelength radiation is of low energy and is usually less harmful, such as radio, microwaves, and infrared. A rainbow shows the visible part of the electromagnetic spectrum, and infrared is located just beyond the red side of the rainbow. Let's learn about the greenhouse effect. What comes to your mind when you hear the greenhouse effect? The greenhouse effect is a natural process in which greenhouse gases such as water vapor, ozone, methane, carbon dioxide, and nitrous oxide trap infrared radiation, which we can describe as heat that in turn increase the temperature of the Earth. In simple words, solar radiation reaches the Earth's atmosphere, where some of the radiation is reflected back into space, while the rest of the sun's energy is absorbed by the land and the oceans and contribute to heating the Earth. The heat radiates from the Earth to space, where some of the heat gets trapped by greenhouse gases just to maintain the warm temperature sustainable for life. These greenhouse gases only make up about 1% of the Earth's atmosphere, which is mostly made up of nitrogen and oxygen gas, which cannot absorb IR rays. The greenhouse gases are still able to absorb about 90% of outgoing IR radiation, which is radiated back to the Earth's surface before being able to escape the atmosphere. Unfortunately, with the increase of carbon dioxide in the atmosphere, more IR radiation is being emitted back to Earth's surface before being able to escape, which causes the overall temperature of Earth's surface to increase due to the amount of radiation absorbed and re-emitted by the greenhouse gases in our atmosphere. As we learn what IR radiation and greenhouse effect are, let's see how they relate to each other. The start of the greenhouse effect starts from the path of solar radiation that reaches the Earth's atmosphere. This solar radiation that reaches the surface is either absorbed or reflected back into space. The solar radiation, most specifically the infrared radiation, is then absorbed by the land and the oceans, which in turn heats the Earth. For this process, the heat radiates from Earth towards space. Furthermore, some of the IR radiation that is trapped by the greenhouse gases within the atmosphere allow for a viable environment for life to flourish. In addition, human activities such as the burning of fossil fuels and deforestation contribute to the increase of greenhouse gases released into the atmosphere. For this increase of greenhouse gases, the Earth's temperature also increases. This greenhouse effect ultimately results in the phenomenon of global warming. If the greenhouse effect is not decreased, a runaway greenhouse effect could take place, where the Earth's atmosphere could be almost entirely made up of carbon dioxide, which would increase atmospheric pressure comparable to over 3,000 feet underwater.
Now we know how IR and greenhouse effect are related to each other. But what about their relation to quantum mechanics? Why are we talking about these two subjects in quantum mechanics course? Quantum mechanics provides the basis for computing the interactions between molecules and radiation. Most of this interaction occurs when the frequency of the radiation closely matches that of the spectral lines of the molecule, determined by the quantization of the modes of vibration and rotation of the molecule. The simple concept of the sun heating up the Earth can give us information that would otherwise be overlooked. For instance, the excitation of the greenhouse gases, water vapor, carbon dioxide, methane, and nitrous oxide causes molecular vibration. The correlation between IR radiation and greenhouse effect is direct. Harmonic oscillator model relation to IR active molecules, carbon dioxide. The vibrations that result from the excitation of the sun rays allow for the perpetual continuation vibrations onto other greenhouse gases. Consequently, the vibrations that occur to the greenhouse gases is then converted into energy. The vibrations most specifically are turned into heat energy, which follow the physical laws of thermodynamics. In continuum, due to the vibrations, we can quantify the amount of energy onto the IR-active molecules using IR gas analyzers. Earth's black body spectrum is another biggest reason for carbon dioxide to increase global warming. In black body emission, the intensity is in the visible portion of the spectrum, where the light being emitted is mainly ultraviolet and near IR. Since Earth is much colder than the Sun, Earth emits much longer wavelength compared to Sun, which emits shorter wavelengths. The IR absorption prevents a portion of the Earth's black body emission from being radiated into space. Without this atmospheric absorption, Earth would be much colder. Carbon dioxide absorbs energy similar to Earth's black body, which is unlike any other greenhouse gases regardless of any temperature. Carbon dioxide absorbs strongly in the regions where water absorption is not very strong. However, as the concentration of carbon dioxide increases, the absorption regions becomes wider and wider, and very few % of radiation is able to transmit from Earth's atmosphere to the space. As we humans produce more and more carbon dioxide, less radiation is transmitted back into space and more black body radiation is trapped, therefore causing the planet to be warmer. Climate change is inherently quantum mechanical. First, the bonds that are broken and made in burning natural gas, oil, or coal are determined by the quantum mechanics that give us molecular orbitals, which control the bond strength. The bond strengths determine the amount of energy that is released by carbon dioxide produced. At an even more fundamental level, the shape of the black body spectrum emitted by the Earth is determined by quantum effects. Planck's explanation of the shape of the black body spectrum and how it changes with the temperature of a hot object was the first application of quantum theory. While massive power plants, vast numbers of cars, trucks, and planes, burning of rainforests, etc., produce the greenhouse gas carbon dioxide, it is the quantum interaction between carbon dioxide and the Earth's infrared black body radiation that produces the greenhouse effect. This natural phenomenon known as the greenhouse effect is a process that we want to manage more closely in the developing years of the 21st century. As the industrial age produced and emitted harmful greenhouse gases into the atmosphere without any regulation, we hope to use current data to adjust and find a solution to recover the damage inflicted upon Mother Earth. To start, countless measures have been put into place by a variety of different countries in respect to deforestation, CO2 emission limits, pollutant regulations, yet we are far from the goal. This goal is very simple, a world that allows for the flourishing of flora and fauna. The political and international regulations put into place are far from perfect, but as we learn better and more sustainable techniques and implement more, with the decrease of these harmful actions done by the hands of humans, we hope to see a decreased greenhouse gas emissions, which would in turn allow for the prevention of global warming. IR radiation would ultimately have less greenhouse gases to excite or otherwise create vibrations that increase energy and consequently create thermal energy that in turn heats up the Earth. You might be wondering, what is the future of IR radiation? Where are researchers planning to go with it? Some of the research being done in this area are using solar power technology to minimize fossil fuel. Some of the researchers have found a way to manipulate IR radiation that will make it possible to be used for high-speed, short-range communication between computers and other devices. Others include building devices that emit and detect specific frequencies of far-infrared light, terahertz radiation, to spot chemical or biological warfare agents such as anthrax bacteria, and to make images of packages or people to find concealed weapons and plastic explosives.